All right, here comes part 2. So we were on example on problem number 8, sorry. We're going to solve a trigonometric equation. So we have a 2 cosine x plus sine 2x equals 0. So what we're doing here is we're doing two things in one problem, checking if you know how to solve a trigonometric equation and if you know how to deal with double angles. Because you have to notice that this is not just an angle, right? It's a 2 times the angle. So we need to deal with that. So if you go back to the formulas I gave you here, then you're going to notice that we have double angles right there. The one we want, let me put it down here. The one we want is a sine, so I want that one, right? I don't want the tangent nor the cosine. I want the sine 2 theta or 2x or whatever the name of the angle will be. So this is the formula I want, right? So we're going to rewrite sine of 2x using that formula. So, oops, so we can see it. 2 cosine x is going to stay as is. And then this one will become 2 sine x cosine x. So 2 sine x cosine x. Again, that's just this here, that double angle, rewritten using the double angle formula. Now that's it. Done. We're going to set that equal to 0 as it is up here. And now we need to see what we can do. Well, we have two terms. We have one term here and we have one term here. Both of those terms have a cosine in it, so I can factor out a cosine. Both of those terms have a factor of 2, so I can factor out a 2. So I will say, okay, I have 2 cosine x. If you factor out the 2 cosine x from 2 cosine x, you're left with just a 1. And if you factor out the 2 cosine x out of 2 sine x cosine x, you're just left with a sine x. And now we use the zero product property, right? We have 2 cosine x is multiplied by this binomial, so we're going to set them equal to 0 separately. And then we're going to just solve for x, right? So here I'm going to divide by 2. That's just 0 divided by 2 is just going to be 0, right? So cosine x equals 0. And then remember, on your unit circle, your cosine is your x value, right? So your x value will be equal to 0 here and here. So x will be equal to pi over 2 and 3 pi over 2. And then isolate your sign here, so subtract 1, so sine of x equals negative 1, and that would happen, so the sign is your y value, so that would happen down here, and this would also be the 3 pi over 2, right? So technically we only have that angle once, right? Even though we're ending up here twice on it. So the solutions will just be pi over 2 and 3 pi over 2. All right. Number 9. So now we're switching to conic sections, right? So we have a parabola and we have the vertex given to us. So I'm going to write that a little bigger here so I can scribble on it. So I have a vertex 6, 3, and I need to remember that this will be my h and my k in my vertex formula. And we have the focus given to us at 4, 3. Okay, so let's graph that already so we can have a little visual, plus we have to graph it anyway, so we might as well do it, right? So the vertex 6, 3, so 6, 3, the vertex will be right there. And then the focus is at 4, 3, so the focus is right here. And I put a little F here, so I know that's my focus. Now that I have those two already, I already know the direction of my parabola, because the focus has to be aligned with the axis of symmetry and inside my parabola. So I know my parabola has to come this way. And that tells me that my equation will be in the form x equals 1 over 4c y minus k squared plus h. Remember, in your equation, when you have an x equals, that's when your parabola opens sideways. How do you know what to put here inside? Well, the k is your y value of the vertex, so k always goes with the y, and then the h is the x value, so that's going to be outside. If we would have used the other formula, if our parabola would have been opening either upside down, like up or down, then we would have used this equation for the parabola. And in that case, we will have the h in it and the k, right? Because the h is the x value of the vertex, so it stays with the x, and then the k will be outside. But we're not in this situation, we're in this one, right? So the k inside with the y, and then the h outside. Alright, so I do know h and k. What I will be missing here is my c value. And to find the c, it's nothing more than the distance away from the vertex. So the distance from the vertex to the focus would be 2. So c is equal to 2. And so now I know what that is, right? 2 times 4 is 8. So I have x is equal to 1 over 8. Y minus, remember I want the k here, so that's a 3, so minus 3 squared plus h, and h is 6. And so this will be my equation, which you would write up here, right? Okay. And then we need the equation of the directrix. Well, we don't have that yet, and we have to graph it too. But we know that it's at the same distance from the vertex than the focus is. So if the focus is 2 away toward the left, then the directrix will be 2 away toward the right. So here is my directrix. Remember, it's a line, right? So make sure you draw a line. And then the equation to that directrix, because this is a vertical line, is going to be x equals, and that equals whatever it is I'm crossing here, and that will be 8. So x equals 8. Alright, I think I did everything. Let me check. So we wrote the equation, we have it, of the parabola. Don't forget your square, right? It has to be a quadratic. And we graphed it, so we have that. We give the equation of the directrix, and we graph it as well. So here is our directrix, everything is graphed, okay? Moving on to number 10. Equation of an ellipse is given, write it standard form. So it's given to us in general form, we need to write it in standard form, meaning we have to complete the square with that. So let's put our x terms together. So 9x squared plus 36x, and then the y terms together. And I'm going to go ahead and move the constant across the equal, so I'm going to subtract 36 from both sides. Here we go. Now that's done, I'm going to start by completing the square. So factor out a 9. Will give me 36 divided by 9 is 4. And I'm going to leave some space here to add the number I need to complete the square in a minute. And now I'm going to factor out a 4 from the y's. And negative 24 divided by 4 will be negative 6y. And here also I'm going to leave a little place because I need to add a number to complete the square for the y's. And then I have my equal negative 36. So what is it I will add? Once I factored out the numbers I need, then I can look at my b value and I can say, okay, this is 4, so take 4 divided by 2 and square it, that will be 4, right? Because 4 divided by 2 is 2 and 2 squared is 4. So I'm adding a 4 here, and I need to add the same amount here, but I'm really adding more than a 4 because this 4 is technically multiplied by the 9, right? So 9 times 4 is 36, so I need to add 36 here. And then for the y, take your b value. Once you factored out what had to be factored out, take that b value, so that's a negative 6 divided by 2, which will be negative 3, square it, that will be positive 9. So I'm going to add a 9, but then again, this 9 is just not just a 9, it's multiplied by 4, and 4 times 9 is 36, so I'm going to add 36. And now I'm ready to factor, because those are now perfect square trinomials, so I completed my square, so I'm ready to factor, so that will be 9 And then in factored form, this trinomial becomes x plus 2. And factor the y trinomial, so that will be y minus 3. And then 36 and 36, negative 36 plus 36 goes to 0, so I'm left with just 36. I am almost done. I need that to be equal to 1, so I'm going to divide by 36 everywhere. And 9 over 36 is 1 over 4. I already had my answer in my head, huh? So that will be over 4. And 4 over 36 will be 1 over 9. So y minus 3 quantity squared all over 9 is equal to 36 over 36, which is 1. So that's the equation that we want to put right here. So you will just recopy it, right? I'm not going to do it now because I have it here for the sake of time. I need the center. Well, the center is going to be given to me by those two values. And remember, inside it's opposite of what you see. So I see a plus here. So my center here will be at negative 2. And that's, I see a minus, so that will be a positive 3. So that's your center. The foci, now we need to remember that with ellipses, the foci will be given to us by doing the c squared is equal to a squared minus b squared. Well, in an ellipse, your a is always your largest one, so that will be 9, and the b will be, not the b, sorry, that's your a squared, that's your b squared. So c squared will be equal to 9 minus 4, because those are already squared, right? And so 9 minus 4 will be 5, and so c will be equal to the square root of 5. Now we also want to think, is this ellipse going to be stretched, oriented horizontally or vertically? Well, your largest number value is below the y, so this ellipse is actually going to be stretched out. I don't want to do it like that because I don't want to. It's going to be vertically, right? So it's going to be oriented this way because the largest value is under the y's. And so my center here will be there. And I need to figure out where would my foci be. And the foci are going to be going toward the vertices, the major vertices, right? So somewhere up here, somewhere down there. How far away from the center? Square root of 5 away, right? That's your distance, your c value. And so how is that going to be affected by the center here? Is it going to affect the x value of the center or the y? Well, it's not moving that way. It's going to be this direction, right? So add square root of 5 to the y of the center and subtract square root of 5 from the y of the center. So the foci will be negative 2 is not changing, right? We're going to stay at the same x value. And then the 3 is where we're going to add and subtract square root of 5. Add to go to this one, subtract to go to the one below. Okay, so that's your foci. 11. We need to give the equation of the asymptotes. Now, I want the equation of the asymptotes. I don't want the equation of the hyperbola, although I have to go through that equation to find the asymptotes. So we need to complete the square first. I don't have a linear x term, so I don't have to complete the square with the x square. It's already finished. And now let's do the y's. So I have a 9, factor that out. If you factor out a 9, 36 divided by 9 will be 4, so plus 4y. And remember to keep a little place here to add whatever we need to complete the square and add 72 to both sides to move that across the equal sign. Okay? Take your b value, which is a 4, divided by 2 and square it, so I'm going to add 4. And then remember to multiply with your coefficient there. Negative 9 times 4 is negative 36, so I'm going to add negative 36 to both sides. And I'm ready to factor that, so I have an x squared minus 9, factor that will be y plus 4 quantity squared, and that will be equal to positive 36. And now I need that equal to 1, so I'm going to divide by 36 here, here, and here. And I'm going to go ahead and simplify and write it here. So that will be x squared over 36 minus And then 9 over 36 is 1/4, so minus y plus 4 quantity squared over 4 is equal to 1. So that's, oh, no, oh, sorry, oh, I messed up. I messed up. Remember I told you that's not what I want there, and then I do it, didn't I? I just showed you what not to do. I don't want the equation of the hyperbola, I want the equation of the asymptote. So let me write that down here in this corner. So this is x squared minus, over 36 minus y plus 4 quantity squared over 4 is equal to 1. All right. The equation of the asymptotes are given to us by doing y is equal to plus or minus the change in the y's over the change in the x's. That's for your slope, right? Of x minus h plus k. Now here we're not squaring because this is just a linear equation, right? So no square. The delta y, well, look at what's below the y. This is your squared value. So if I just want the change in y, I don't want the square value of that. I want the square root of that. So that's a 2. So my delta, let me write that in color. So my delta y is going to be equal to 2. And my delta x is going to be, this is the value squared, so that will be 6, right? So now I can write my equation. My h value, the center of this hyperbola, will be at 0, -4. And that will be my h and my k, right? So we have everything we need to write the equation. So it will be y equals plus or minus. Don't forget the plus or minus because you need one asymptote to go up and one asymptote to come down. So one slope positive, one slope negative. And now let's put the slopes down. Delta y over delta x. So 2 over 6. Can we simplify? 2 over 6 will be 1/3, right? So 1/3. And then x minus h, h being 0, I really don't even need that parenthesis because x minus 0 is just x. And then plus h, plus k, and that's a -4, so -4. So that would be your equation right there. Almost done. All right, so now we have to, here we are just really matching. So we have 4 graphs given to us, 4 equations, and we need to match them, right? So I'm looking for the parabola. It's really easy because the parabola has only one variable that's squared, right? Remember I wrote down the equations earlier, didn't I? Yes, I did. The equation when the parabola opens sideways is x equals something with a y squared in it. Only one of the variables is squared, not the other one. If the parabola opens up or down, the y is here and then the x is squared, right? But you never have both of the variables squared. So we're looking for an equation that has only one of the variables squared. Here we have an x squared and a y squared, not this one. X squared, y squared, not this one. X squared, no y squared. This one right there is your parabola. Has to be. So C will be I, the parabola, right? I'm actually going to write that next to it because it makes it easier, parabola. Okay. Then the next easy one to spot will be the hyperbola, because the hyperbola has both variables squared, but one of them has to be subtracted, has to have a negative. So look, if I look at those, both of those have a variable, an x squared and a y squared, but both of them are positive, so that's not a hyperbola. Here, both of those are squared, but they're both positive, not a hyperbola. I have an x squared and a y squared, but the y is negative, is subtracted, that's your hyperbola. So A will be my hyperbola 4. So A will be, and I'm going to write that down, and I would like for you to do that too, hyperbola. Okay? Now we have 2 to go, that's B and C. And so both of those are going to have both variables squared, right? X squared, y squared, x squared, y squared. But the circle is as far from the center in that direction, then it will be in that direction, right? So the major axis, the axis is going to be the same length both ways. In an ellipse, from the center, there is one direction that's going to be longer than the other, right? That's when you have an ellipse. So for us to be able to see that in an equation, for the circle, the x and the y squared need to have the same coefficient because they're going to be the same distance from the center in both directions. For an ellipse, the x and the y squared should have two different coefficients. So when we're looking here, x and y squared, they both have a 1 in the front. That's the same coefficient. That's your circle right there. So B will be my circle. And the ellipse, when you're checking x squared and y squared, you see how this one has a coefficient of 1, this one is 6. They're two different coefficients, but they're both positive, so you know that's an ellipse. So this one is your ellipse. So ellipse D is this one. Okay. Logarithms. So I think we did all of those together, but let's just re-emphasize. So we have a base 6, and then there is a 6 here. So I'd like to rewrite that log so that I have the base and the inside of the log that are the same, and then to an exponent, right? Because then that will just be equal to n, to the exponent, because those two will be inverse operation of each other, so they cancel each other out. So let's try to do that. We're going to rewrite that cube root using an exponent. So that's going to be a log base 6. And instead of having a cube root, we're going to have 1 over 6 to the 1/3. A 1/3 exponent is a cube root. Then I don't want my 6 down here because I need it up here in the numerator, so I'm going to move it up, and when we do that, it's negating the exponent, right? So base 6, the 6 is going to be moved up, and what happens to the 1? Well, 1 times 6 is just going to be 6, right? So there it goes, and then the 1/3, but we're going to have it negative because we moved that up. Those two are now the same, they cancel each other out, they're inverse operation of each other, so that's just going to be negative 1/3. For B, you can do that two different ways, but the first thing I noticed here is that I have a base 4 and a base 4. So I said, oh, when I have the same bases and I am adding the logs, I can write that as one single log with that same base, multiplying their inside. So 2 times 32 is 64. Then I'm asking myself, 4 to what exponent gives me 64? Well, that will be a 3. Because 4 cubed will be 64. So that should be a 3. Okay? Here we're expanding. So we have a division. That means we're going to have two logs, one for the numerator, one for the denominator. So that will be equal to the natural log of 3. And because it's a division, we're subtracting the logs. Natural log of whatever was in the denominator, which is x squared plus 1. Now, this is a root which can be rewritten as an exponent, so I'm going to rewrite that as a natural log of 3 minus the natural log of x squared plus 1 to the 1/2 power, right? Now, why did I need to do that? Because remember, my job is to expand, so I have to expand as much as I can, and this exponent can be brought to the front of the log as a coefficient. So that will become the natural log of 3 minus, and then that exponent becomes a coefficient of 1/2, and then the natural log of x squared plus 1. And we can't do anything with that because this is inside a log, and there is no property that says you can break an addition inside your log, right? So this is it. That's your answer. Now we go the other way around. We're condensing. So we have two logs. We need to write them as one. I notice a little 2 in the front here, so I already know that I can bring that inside as an exponent. So that will be a natural log of E to the 6th, and then bring that in will be to the 2nd. When you have a power to a power, you just multiply them. But let's just go through this one for a minute. We're going to have a minus a natural log e to the 5th. And we want to rewrite that root as an exponent. And by now we all should know that should be a 1/2 exponent, right? A square root. Okay? We have a power to a power. When you have an exponent to an exponent, you just multiply them, right? So that will be equal to the natural log of e to the 6 times 2, which is 12, minus the natural log of e to the 5 to the 1/2. So multiply those two will be e to the 5/2. And the base we don't see here for a natural log is the base e. So when the base and the inside of the log are the same, they're inverse operation of each other, so they cancel. And so I'm left with just my 12 here. So that will be equal to 12. And it's the same situation here. I have a base c and an e inside, so I'm left with just 5/2, so minus 5/2. And now just do your common denominator, right? So multiply that by 2 is 24, and 24 minus 5 is 19. So I'm ending up with 19/2. All right, one more thing. Log. So here I have a little typo here. We should have an opening parenthesis here. So let's make sure we put that there. I am adding two logs, so the property of logs says that when you're adding two logs, you can actually multiply their insides. So I have a log base 10, right? The base are the same, of 5x times x minus 1. All of that inside the log, and then it's equal to 2. Now we can say, what is the question this is asking me? It says the base to that exponent has to be equal to the inside of the log. So the base I don't see is a 10 here. So 10 to that exponent, right? The base I don't see here is a 10. So 10 to that power has to be equal to the inside of the log. I'm just going to go ahead when I write it down to go ahead and multiply that through right away. So 5x squared minus 5x. Just distributive property. And here now we have that's a quadratic equation. 10 squared is 100. So I'm going to set that equal to 0 and say 5x squared minus 5x. Subtract the 100 from both sides. And that's what I would have. And then I notice that I have a factor of 5 everywhere. So I can divide by 5 everywhere. That will give me x squared minus x minus 20. And now I can factor that. So 0 equals, what can you multiply to give us a negative 20 and add up to give us a negative 1? That would be negative 5 and positive 4. So x minus 5, x plus 4. And we, remember, want to solve. So now we're going to set them separately equal to 0. So x minus 5 equals 0. Therefore, x equals 5. And x plus 4 equals 0. Therefore, x equals negative 4. Oops. I was thinking about my 5 over there and I wrote 5. X equals negative 4. Now with logs, you always have to be careful that your solutions are not extraneous, right? Something sometimes could happen as you're solving equations. And it did here. Because when I take my 5 and I put it back to my very original problem, if that's a 5, 5 minus 1 is 4, I can have a log of 4. That's a positive number inside the log and will be good. Try the next one. 5, if I change that to a 5, 5 times 5 is 25, that will be good. So the 5 is definitely a solution because it works with both of my original ones. So x equals 5 is good. Now let's try the negative 4. If you put in a negative 4 here, negative 4 minus 1 is negative 5, you cannot have a negative inside the log. So we don't even have to try the other one. We already know this is not a solution. It is extraneous, we call that. Those are solutions that happen algebraically when you do your work to solve, but they don't fit your original problem, right? They're extraneous. So the only solution we have here is x equals 5. All right, that's it.